instructor. I'm Rajat, and yeah, Kartikeya Agrawal and Pooja Pari. Yeah.
Yes, sir. Sir, actually, I have doubt in week 1. Can I ask?
Okay. Wait. And mm,
Just a small doubt.
yes, yes. Okay. So everyone joined, I think, 12. Mm, okay. Ask your doubt. What is your doubt?
Sir, in lecture 1.7, sir has
Oh,
explained us a string method and add method. Can you explain? I don't get it. Why we use that?
in lecture
Lecture.
1.7.
Yes, sir.
I replied to your comment also that
Yes,
string
sir.
method. Yes, actually, string method is to means if you want to convert your value to a string, like if there is a 1 or 2 3 integer something. So if you want to convert this as a string, you are taking as a string, so you can use str method. If you put anything in the str and bracket something, anything, so it will
Okay.
take as a string. If means if it is, if you are like if you are solving problem which requires a string and string kind of thing, so maybe because in the Python already it takes anything as a string, but if you specifically require any programming question to take it as a string, so we can put str something. So and the second one was the add method. So
Yes.
in the add method, actually what we do uh, in the class something, if we like 1 plus 2 is 3. Okay, so but if we are dealing with the object, like we suppose we have a class car. Okay, so class car has a two object. So car has a two types of object, like any model of the car can have. So we can have any model of car like Maruti Suzuki and any other model, BMW or anything. So how to add with these two objects? So there we can add, means if we insert, if we use that add method to add the object, then we can then we will have this kind of thing, that add method. So this was the I referred in the uh, discourse forum also.
Sir, add method is not clear yet.
It's like adding two objects. If I can say that what is in the means if I want to add two objects, then so maybe one thing, like what to say. So there is like we are dealing with the car. Okay, so in the car, so if we want to concatenate and if we want to add two object, there is not like 1 plus 2 is equal to 3 or something like. So we are dealing with the object kind of thing. Then we can, so we cannot add directly, like means we cannot add, yeah, this car plus car 1 plus car 2, car 1 plus car 2 to add those two objects, or so it will not work in Python, right? So in general thing also it will not work. So that's why we can use, we have an inbuilt function. This is an inbuilt function, str also. This is inbuilt function in Python. So we can use there to add two objects.
Okay, sir. But in lecture 1.8, where sir implementation of the code is given in 5.39 minutes, adds it's self comma p, but we are adding p plus q. Then how it will gonna work?
So p and q is object.
So it is taking p as a, okay, I got it.
Ah,
Okay, sir. Thank you.
wait. more people
Hello,
have.
sir.
Yes.
Sir,
Hello.
can I ask?
Yes.
Sir, can I ask week two regarding question?
Please refer
The,
to the section also, that what is the section.
yes, sir. Actually, not any particular section. I mean, can you explain the complexity calculation with an example? I mean, T of n equal 2T of n by 2 or such. I mean, how we can compute the complexity? Can you explain with an example? I mean, step by step.
So uh, okay, so suppose uh, suppose you have a let's start with the basic concept of time complexity, right? So
Yes, sir.
so like you have a any kind of loop you are calculating. So we have a for loop, a general for loop, I is equal to 1 to n. Okay, so this is the for loop, and we are doing something. So what it is doing in the for loop, so it is iterating 1 to n times. It is doing anything 1 to n times, anything in the loop. It is doing 1 to n times, so there will be the complexity will be order of n. So this is doing n time, no? Right? So we are calculating it as a order of n. Suppose, and let's suppose we have a for loop, nested for loop. Okay, so we have a for loop and another for loop inside this original loop. Okay, so then uh, what it will does, what do you think what it will does? So if we have a for loop I is equal to 1 to n, right, and another for loop within this for loop, which is I is equal to 1 to m, suppose 1 to m. So
Yes,
what
then m into n will be the time complexity.
so no, I'm yeah, it's a correct time complexity, but I'm talking about me because you just asked a basic question. So how it is calculating, means what is how it is m into n, how it comes m into n.
Okay, so for each n elements in the outer loop, we are running the inner loop m times. I mean, for each one element, we running m times. So
Yes.
m plus m n times. So m
Huh.
into n.
So that's why it is m into n. So this is the this by this way we can calculate. Let's suppose we have a in a program, in any program we have a two nested for loop like m into n kind of thing, and some program, and in the same program we are running another for loop like 1 to n for I is equal to 1 to n, and that's all. There means one program has a two program means two for loop. One is nested for loop and one is another for loop which is not in the nested, which is not related to that for loop. So what do
Okay,
you
so
think?
one outer for loop and inside that two inner for loop.
No. One is nested for loop. Okay, means one for loop with the nested one. So this is one and another for loop which is not related to that for loop. Okay,
Okay, so
so
maximum of the I mean the nested for loop and the simple for loop, within those the maximum time complexity will be the dominant.
that's why
Is it?
yes. So because it will take m into n, uh, time complexity is m into n, and another one takes order of n time complexity, so we will take maximum. Why we will take maximum? Because that we are, suppose this is doing a order of n square, this is doing order of n, so we will take maximum as a what the program is taking. So order of n square or order of mn, we will uh, take it as. Okay, so
Yes, sir.
this is the way to suppose in the we are I'm coming to your specific doubt. Suppose that we have a time recurrence relation So
Yes,
T of,
yes, sir. So up to iterative, it is clear to me, but I am actually facing difficulty in the recursive
so
method.
I'm
That
coming
how
to the,
it
yes,
will be.
yes, yes. Yeah, I'm coming to that one. So this is, we can calculate these thing with these time complexity in various methods. So one is the recurrence relation method. So there are another way, various method to solve recurrence relation like master algorithm and all. So here we will not go into that. And this is called a tree method also. Like T of n is equal to, suppose we have a recurrence relation, T of n is equal to 2 T of n minus 1. Okay,
Yes,
right?
sir. Can you please write down and explain? Then it will be better to understand.
uh, okay. uh, I'm sharing my screen. Okay, uh, can you see?
Yes, sir. It's visible.
Hmm. So what do you think? uh, so 2 T of n is equal to 2 T n minus 1. This is the recurrence relation we have. So uh, first you approach, then I'll uh, point out what you are means doing wrong and all. What
Uh,
means
actually, sir,
whatever you.
actually, I am asking that how to come in this expression from code given. I mean, a code is given, and how to know that this expression.
Okay,
That is my question.
okay. So mm, okay, I'm writing anything. uh, hmm. So what we are doing here, that is, any function is here. We are dealing with any numbers, and so n is any number. So we are again, if this function return anything, there is a some statement that like breaking statement, there should be a some breaking statement. We will not go into that. So this is the
Recurrence relation.
so this is recurrence relation. So it, what it is doing, it is calling itself like fun n minus 1, you know, the recursion method. So this is fun n minus 1, it is calling itself. again and again, n-1, there should be a breaking statement. If we are getting negative number, then we'll break that function. Otherwise this will call and then we'll calculate this, and then it will go to this one. Okay,
Yes, sir.
so then it will calculate this function, and then it will return here, and then it will call, and if it goes on when something breaks here. Okay, so this is our program. So we have to write the recurrence relation for this one. So we can have t of n, means t of n we want to calculate that what will be
Yeah.
the recurrence relation, time complexity, recurrence. So t of n is the our program. So what it is doing, it is doing n-1 times, right? Means it is calling itself n-1 times, right?
Yeah,
First
but
one, first,
there is two fun of n-1.
so
So
yes,
should
yes.
it be 2 into n-1 or?
So what yeah, so what it is doing means, first it will, first one function n minus the basic recurrence is like calling a function in stack and storing into the stack, call stack kind of thing. So here fun n-1 is calling itself again and again n-1 times. So what is the time complexity? Suppose Tn is the time complexity of the Tn is the recurrence relation for this whole function. So for n-1, what it will be? T of n-1.
Yes, sir.
So what do you think? What will be the recurrence relation?
Yes, so 2 into two into Tn-1.
So because yeah, it will calling itself n-1 times, and this will all again it will call itself n-1 time. So for Tn is the whole, we want to know what is Tn for whole function. So here we can say n-1 time for Tn-1 plus Tn-1 for n-1 times. So basically what is the idea behind it? To form the recurrence relation, any kind of function, if you are saying any kind of function, so idea is to what times it is calling. So first thing is to means how much times it is calling or something, it is calculating, loop is calculating how much time it is calculating, and the which functions and which things are used to calculate, though means calculating, and which things are taking part of your programming. So we will calculate all those things. If we maybe we can say that plus one also here, plus one also. Why plus one? Because for any times, this is for n-1 and n-1 time. Whenever it comes to return function, then it will calculate n-1 times or n-1 times. But before coming to these terms, it will just it will first go through the def function, and it will again, it will execute that function, then it will come to return function. So that's why we can add plus one also here. So but plus one is not required here to means it is not much, it doesn't take much part in the time complexity to calculate time complexity. So this is the way to calculate time complexity on recurrence relation. So you got it, or
Yes, sir. So what will be the answer? Tn equal to 2 into n 2Tn-1 uh, plus 1 or something else, or plus n. I mean, in some expression that is Tn equal to 2Tn-1 plus n. Somewhere it is plus 1. So how to find that
uh,
it is plus 1 or plus n?
yeah, that's what I am saying. Yes, yes, that's what I am saying, that you first any program you need to find out the uh, means what is taking part in the expression in the program, what it's like to calculate anything which, like here we are doing anything, so function is how much time it is running or loop is running. So we need to focus on those area, that here plus one, why we wrote here a plus one, because plus one is for calculating, because first only one time like any numbers comes, then it will go to def fun one and then it will execute, so we are counting it as a plus one. So that's why we calculated it as a plus one. Otherwise fun and minus one and fun and minus one, so it's and every time it will take as a means n minus one times n minus one times. So uh, coming to your point, we have to means focus on the area where it is majorly a logic part, what it is taking. Like in the program we just define some variable, like, so it will not take part in the logical thing, so we will not consider those things. And if we have a for loop, so we will think that so this is the part, this is the area we will focus here, so t of n into t of n into t of n. So that kind of thing we will do here. So plus one is for executing one
Yes.
time code.
Okay, so
If there is
so here it will be Tn equal Tn minus 1 plus 1.
no,
Is it?
no, you were right earlier hello.
Yes, sir.
So what will be the answer? Mean
So I think 2 into Tn minus 1 plus 1. Is it?
2 into t.
N minus 1 plus 1.
Yes.
But sir, can I ask in this question, sir? But
Yes.
the Vigo notation is the n factorial. So how to do this actually? I had also some question here to ask, because actually not sure that if this question is okay, but if in general question comes, then how to go further, how to go proceed this type of question.
Sorry, I didn't understand your question.
Yes,
What you are
in same question, sir. If
saying?
we are solving the first question, the exercise, so its Bigo notation is n factorial.
Oh, okay.
No, not n factorial, 2 to the power n. Sorry, that
Mm,
this Bigo notation is 2 to the power n. How to calculate that Bigo notation? The first question.
uh, you are talking about this one?
Yes, sir. Yes.
So, so what you are saying about this question? Factorial n?
No. The actually I made this first of all in the t to the power. The t is answer is coming no t n minus one. So I
But
was little, yeah, I was little confused how to calculate the first of Tn, and the second one is the Vigo notation is 2 to the power 1. Actually, I'm telling you the way I thought.
so what
I
you
thought
yes, you
I
tell your thought.
Yeah. So I thought that first it will go recursion, it is the recursion. So first it will return in the first recursion function, it will enter. So yeah, suppose n equal to take 5. I'm taking n equal to 5 here. So it will enter in the first recursion, it will go the 5 depth down. The time of returning the 5th depth, it will enter in the second recursion, isn't it? So for every returning time, every recursion will take n times in the right side of recursion.
Why?
That's why the recursion the works. So this recursion will make a tree diagram, no sir? First, suppose there is a two recursion here returning with plus,
Yes.
no? So
Huh.
first it will return in the first recursion, then it will not go in the second recursion at the same time.
Yes.
It will
Yes.
it will go inside.
Yes.
So
Yes.
suppose n equal to 5, then it will go depth of the 5. The time of returning the 5th depth, it will enter in the second recursion,
Huh. So
isn't it?
wait. So what how recursion works, like we suppose it will goes to a program and then return function and then it will go to write fun and minus one. Okay.
Yeah, so first time it
So
will go right side when it will
huh,
returning of the first, the right,
so
yeah.
then anything comes here fun and minus one, so
Mhm.
it will return the here the right one fun and minus one plus
Mhm.
means fun and minus one left one side. Okay, then fun and minus one, that it will be fun and minus two plus something whatever it returns here, so it will return here, okay, in the fun and minus one section. Then after it will go to that section and then it will return here. So then after the break, whenever breaks statement occurs, then it will calculate whole these things, then it will go to the left fun and minus one and then it will calculate the same way and then it will add something, then the final results come. So this is how recursion works. So are
uh,
you saying this one or
I think that it will not go the first one. First one, it will uh, at the
why?
end it will go and it will come out.
Why?
Uh, so it will be easier if we make the draw the diagrams. So can we draw diagram somewhere in the whiteboard? Then it will easier to understand.
uh,
So
why means why you are saying that it will not go to fun and minus one? Why means it won't calculate fun and minus one?
sir, is it better to use the two function, because that no the talking is because both function in fun minus one. So it's confusing which fun minus one we are talking.
So let's suppose we are talking about
If
right
it is
fun
the
and minus.
Fibonacci, then it will be better.
So we
Okay.
are huh,
So first it will, I think that once the inter, once I will call the fun 5, suppose,
huh,
then it will go it will become fun 4, fun 3, first fun 3, fun 2, 1. And
hmm.
the time it will become fun 0 or 1, whatever the time it will return. So the time of returning, it will go in the fun 2, isn't it?
Fun two means yes, of course.
It will go in the fun 2, and the fun 2 will return his
uh,
calculation. Then fun 1 and fun 2 will add together, and it will again go uh, the fun 1 of the 2. Very
huh.
confusing to say like that.
Wait. uh, so okay, so wait, we have a one query. Wait uh, uh, so uh, Pooja Parik, so what is your query?
Hi, hi Rajat. I wanted to ask that day before yesterday on Monday, I got a email regarding you have been invited to join this PDSA September
Oh,
2021
sorry,
Replit.
sorry. I mean, it was not related to this question, right?
No. It's related to this rep, but it's a
Okay,
small.
so we will,
Okay, it's a
yeah.
small question actually. Yeah.
So we will discuss this after this question. Okay.
Okay.
Uh,
Thanks.
Sir, I have one question. Why is it 2 minus 1 plus 1? Why it is plus?
so everyone will ask this right now. Means what is the query about these things? Okay. So what is your query, all of you? Hello.
Sir, I have sent. I just sent one link. Can you use the link where we can draw the graph also, so it will be easier.
Okay. No, I am asking everyone that anyone has a query.
Sir, I have one question.
No, means regarding this question that
Yes,
we
Sir,
are.
I have a query regarding this.
sorry, can I ask first because I raised.
Yeah, please go ahead. Yeah, please go ahead.
Why is it plus 1?
Okay, and what? Oh, that's all, right?
Yeah.
Okay, and what is your?
Yes, sir. I wanted to ask, is it an efficient way of writing, right? Return fun in minus one plus fun in minus one. Then we are forcing the program to calculate fun in minus one twice. We are making making it do same work twice. If I can write 2 into fun in minus one, then it will only calculate the value of fun in minus one once. Wouldn't that be more efficient way of writing it rather than this?
Okay, and anything else?
I have a different query about something else which I'll ask later. I have hand raised.
Okay. Means not related to this one, right? Okay. First this one we plus one is for if any program coming to upwards means upward to downward. So plus one, why we are adding this plus one? Because suppose it coming from upward, and then there is a something function comes here, fun and fun 5, and then it will go to that section return fn minus 1. So it executes one time, right? It executes one time, that's why we added here plus 1. Then after it will go to this section fun and minus 1, whatever it will be, but first it goes to this one, that fun 5 is equal to and all, it executed and all. So that's why we added here plus 1.
Okay, sir.
So let's come to this question. Okay, so Where is eraser? You know, eraser. Huh. Hello.
Yes, sir.
So it will go on this way. Okay, so f5 is there.
Yes,
So
sir.
then it will go f4,
Yes,
then
sir.
it will go f3, then it will go f2, then it will go f1, then it will go f0. Suppose
Yes,
0 is breaking. Suppose we are taking that example in the same example.
yes, sir.
So f0, suppose here it is returning 1. So here it
Yes,
will calculate 1. Then here what it returns 1. Okay, f0 is 1.
yes,
So then
correct.
it will go
Then it will not go F1, it will go other
1.
place.
Which place?
Can I write, sir, my thought here?
So
It will go another F n minus 1, right side one.
so this, okay, means this is calculating in this way, like f0 is 1, f0 is 1. Okay, so it will calculate it as 1 plus this one, means it will just return this statement and then it will comes to that f1. So what you are saying?
Uh, I'm telling that the time when the F0 will return to 1, no?
Huh.
Then after returning, it will go another F right side of F minus 1 value I to calculate first.
F minus 1.
F whatever that time n value will be there.
Sorry, but we what I'm saying that it will return here because n is equal to 0 is breaking. N is equal to 0 is the breaking statement. So it will just go to that one, means f0 is equal to 1. So it will just return 1 here. Then it will go back 1, means it will just
But
so we
yeah,
are forwarding this way. Okay, 5 4 3 2 1 0. So then even when the breaking statement comes, then recursion goes to backward also. So then it will just return where, means it will return where it started. So that's why, that's how we that's how recursion works here.
yes, that's got, sir. So it is coming the 2 to the power n
Huh.
to the big O notation. So I wanted to calculate that how to calculate the very efficient way, the 2 to the power 1 this way.
No, I didn't get you, means what you are saying.
So the big O notation of this program for this algorithm,
Huh.
we are getting 2 to the power n.
Huh.
So
Means
how
it is, yeah.
2 to the power n steps
Huh.
means in degree. So how to calculate that way? So can I, sir, can I write that whatever I thought here?
You can write.
Okay. Suppose here is the t to the power I'm taking the uh, the f function. This is the f5. F5. So it will go down it will become F4 and F4 plus F4.
Hello.
Hello, sir.
Yes.
I'm writing the down. Can you screen? Can you move the screen little down, sir?
Um, mm,
So please scroll up the screen.
yeah, scrolling. Hmm. Hmm. Can you draw above above?
Okay, sir.
Yeah,
Okay, sir. I'm trying to.
yeah. Above the TN above the TN. We can
Okay,
see. So
I'm going up, sir.
yes.
From here is fine, sir.
Uh, yes, you can write. Where are you writing? Yes. Yes. Right here. Uh,
Here I'm writing, sir. Oh, here I'm writing, sir.
okay.
So I'm writing here F.
First write your all statement.
Yeah, F high. So F high will become once it will go F high will become F4 plus F4, and then it will go first in this. So it will become F3 plus F3, and then it will go in the again first. So it will become F2 plus F2, and it will again go in the next depth. Then it will become F1 plus F1
Plus.
F1, and then again it will go in the depth. So it will become F0 plus F0.
Whatever. Yes.
Isn't it, sir?
Yes, that's what I'm saying. Yeah, it will return wherever it started.
So when the F0 is there, then it will return to this value 1. F0 itself will return to this value 1. And once it will return 1, then after this 1 will go to in that portion. After executing the 1, then it will go to execute this one. So this is the next steps. So suppose it's the 1, 2, 3, 4, 5. So this is the 5th steps. So this will become the 6th steps. It will go the right side. Once this entire thing will be calculated and it will become the 2, then this 2 will come to this F1, and then after this this will become right now F2, F1 will become 2, then it will go here. and then this f1 will again go further to return the what. Then this process again, iteration will again start from here, a new iteration. So this all be, it will start calculating. I thought like that, sir.
Yes, you are correct. So that's what I'm saying, that it will return wherever it started. Means wherever it started, it will return those things. Means it will goes f5, f4, f3, f2, f1, and it will calculate those things. Because why we are calculate, why it is going, because f5 is going f4, so f4 will again go to f3 plus f3. So f3 plus f3, then f3, f2, f1, f0, it will break there, and then it will calculate, and then it will return the statement. That's how recursion works. It will store into the stack also, uh, call stack, we can say that call stack.
Yes. So now thing is that how to calculate the mathematical calculation from here to get the the bigger notation. The iteration way is very easy to find the bigger notation. Problem comes a little bit when the recursion comes, and the recursion comes with the many branches.
So that's why, so that's why we are we whenever we suppose you have a, we have a 5 means n is equal to 5 here. So suppose we have n is equal to 100. So how do you calculate the means how do you calculate this recurrence
Correct.
relation, or so how do you calculate? You have to write any relation kind of thing for generalization. Otherwise we cannot calculate, we will forget many steps there. So that's why
Yes, yes, yes.
we write recurrence relation.
So from here, how actually we got a recurrence relation? Because
Yeah,
once I was solving this question,
yeah,
it was taking so much time to think. So suppose
yeah, here
if it, yeah.
I have written here, tn is tn has a two branches, like tn minus 1 and tn minus 1. So for, so yeah, okay. So here you have written f5 is equal to f4 plus f4, okay.
Yes,
Huh. So f4 plus f4. So that's what it is doing. Like, see, tn t5 is equal to t4 plus t4. Then again it will go t4 t4 into t3 plus t3. Then here it will also go t3 plus t3. So that's what we are drawing here, tn, but in terms of tn. So it's the same. You see
yes,
here, it's the
yes,
same.
yes, yes.
It's same. So it's a generalization kind of thing. Means it's a generalization of your problem. Same, right?
Yes, yes, yes,
Agree? So
yes,
that's
yes,
why we calculated tn is equal to 2 tn minus 1, because of this plus statement there. Plus we are calling two function, right? Plus fn minus 1 plus fn minus 1. That's why tn is equal to 2 tn minus 1 plus something, whatever it is. So uh, means each time whatever we are taking, can you mute? So in this question, we are dividing our statement, our problem into two parts, like tn minus 1 and tn minus 1. So again we are dividing it into two parts, like tn minus 1 and tn minus 2 into tn minus 2. So each time whenever you see that this kind of statement, like tn minus 1 plus tn minus 1, so we can write it as a 2 tn minus 1, and again tn minus 1 will break into two parts. So every time you see that every time, so 2 into tn minus 1, we can, okay, I'll write. So sorry. So you can see there we are calculate every time it gets separated into two parts, 2 into 2 into 2 into tn minus 3. So tn minus 3, then after it will go 2 into 2 into 2 into 2 into n minus 4. Why this is 2 2 2 every time? Because it is just we are separating into two parts, dividing into two parts. That's why 2 is every time 2 is here. So I want to ask you, everyone, do you have any doubt up to this?
No, sir, I got it.
Yes, sir.
No, no, no.
I have a doubt.
Everyone.
Sir, I have a doubt.
Huh.
My doubt is if I write f of n equals to f of n minus 1 plus f of n minus 1 plus some constant, then, and in another program if I write f of n equals 2 into f of n minus 1 plus some constant, so they will have different complexities, right?
You have asked your question.
Yeah, because in my head I think if I write f of n equals 2 into f of n minus 1, it will take theta n time, and if I write f of n equals to f of n minus 1 plus f of n minus 1, it will take theta exponential time, I think theta to the power n time. Is it correct?
So what do you think? Is it correct or not? Means, what do you think? Because obviously, because I took this example as a generally example, means I am not calculating. I was not calculating time complexity.
No, I'm talking about this example.
I'm
talking
coming
about
to your
this example.
question.
If I write, yeah, okay.
I'm coming to your question. So you are saying that if we are rather than using fn minus 1 plus fn minus 1, we will calculate 2 into fn minus 1, right?
Yes.
So let's do this here. So wait, so what here means what will be the next step here?
It will be 2 to the power 2 f3.
So 2 to the power 2 f3, and then it will 2 to the power 3 f2.
To the power 3 f2.
Then it will goes, suppose f0 is equal to 1, right?
Okay.
So then what it will calculate? 2 to the power 2 f3, then 2 to the power 3 f2, then 2 to the power 4 f1, then
2 to the power 5 f0.
So 2 to the power 5 f0. F0 is what?
F0 is the base case. Let's say F0 is 1.
F0 is 1. So here we got that this is 2 to the power 5.
No, I'm saying that this tree has 5 levels, and in each level I am doing constant work, right?
2 times. Each time.
No, I'm just multiplying by 2. I am doing constant work.
Yes. Means we are just multiplying that. This is the constant kind of thing. So 2 into something
This will have, yeah, this will have a linear time complexity, right?
linear time complexity. Yes, that's what
But if I write if
that's
n
what
minus
I'm
plus if,
asking.
yeah, if I write if n minus 1 plus f n minus 1, then it will have a binary. Then the each level, the number of problems I have to solve will double, right? The first level will have one problem, the second level will have two problems, the third level will have two problems. So it will grow
Okay,
exponentially.
so you want to know exact answer. So I'm just saying that this will have a less complexity because of the linear times of we are multiplying just 2 into something. So because we are at each step we are just calculating one thing, means fn minus 1 fn minus 1. Okay, so but in this step fn minus 1 plus fn minus 1, we are just dealing with the two steps fn minus 1 plus fn minus 1. So definitely the time complexity will be double here, means time complexity will be more here, but and time complexity of this program with it program will take less time because of, you know, that this is a linear time multiplication, linear time, because
Yes.
2 into something. Yeah, so means that's what I am saying, that I wanted to I wanted to involve you in this concept. That's why the exact result is this, but you know the procedure. So
Yes, sir. Yes, sir.
so is it your doubt cleared, or means because I know
No,
you
my original question was what is a good practice? Is it a good practice to write fn minus 1 plus fn minus 1 or 2 into fn minus 1? So this is the this is the answer to that question. I got my answer. I have to write 2 into fn minus 1 if I to
okay.
right?
Okay, so sometimes like if we suppose we are dealing with the Fibonacci number or something Fibonacci number, so we need to write fn minus 2 or fn minus 1. But if we are doing the same kind of thing like fn minus 1, if this is the same thing, so we can have a 2 into fn minus 1. This is the good thing because it will take less time. But sometimes according to the question, if it is fn minus 2 fn minus 1, n minus 1 is not, means n minus 1 is here and n minus 1 is there, and then it is good idea to write 2 into fn minus 1. But but if we are dealing with this different number, so we have to write
Yeah, for Fibonacci, I think we are solving two different problems for solving the original problem. So that will be exponential.
So whatever it will be, but yeah, so anyone has a doubt, means whatever you can ask, means related to this question, anything, please specific, stick, means stick to this question. Any doubt you can ask. Okay.
So if you're done with this, can I ask my question? I have my hand raised since 7 p.m.
Can I ask mine actually? It's been quite a time, like.
Yes.
Yeah,
Just have a small question. Yeah. Actually, I wanted to ask that on Monday, I received an email that I have been invited to join this PDSA SET 201 on Repli. So when I joined, actually I joined like in the evening, and then I saw that there are a set of problems, and there is some due date is given. So is it a graded assignment or because actually when I checked the due date, 5 of the problems had due date on 11th of September, and the other 2 had 13th September. So by night 13th. So I could not do any of those. What is it about? Is it the graded assignment, or because I did not see any announcement also regarding these?
No, sorry, that was live. You were talking about live coding session, right? That last.
This is the live coding session.
That was the live coding session, and it was
Okay.
not graded kind of thing. So you can
Okay.
again means that question is there. You can so you can attend that question, but so
Okay.
locally you can attend that question, but it was not graded. So don't worry.
Okay. It is for the live coding session. Okay.
It was live coding session.
Okay. So every time we have this coding session, we will have it in similarly in the Replit. Okay.
Friday. Friday.
Yes. I think.
Friday or Saturday.
Every Saturday.
Okay.
See, Rajat, just hang on. Let me be clear on that. So, hi, it's Omkar, the other co-instructor for the course. So the thing is, we conducted that live session Saturday from 5 to 7, right? And during that session, whoever was available, we shared that Replit link with them. They joined that and they practiced there. I mean, they did that live coding. And after that, we thought that it should be accessible to everyone. And YouTube link is accessible, but you cannot do this coding on YouTube link, right? So you should get access to this Replit also. That's why we shared I only shared that on Discourse.
Okay, that's a very good idea. Yeah, thank you so much.
So now you cannot submit because the deadline has been passed, but you can keep practicing whenever you want. And that same Replit will be used throughout 12 weeks of this course. So now you do not have to join new Replit every time, but new set of problems will be added there for every week's that live coding session on every Saturday. That's how it will be.
Okay.
If possible, better you join that session and do coding during session. But for some reason it's not possible, you can practice later.
These will be available throughout the semester, right?
Yes, they will be. They will be available on Replit throughout semester, and they are not graded. They are only for practice.
Okay. Thanks a lot.
All right. Yeah.
Sorry, I missed the session.
Yeah, it's fine. So every Saturday we'll have that live coding session from 5 to 7.
Yeah, that's great.
Yeah. Rajat, one more thing. People have raised their hands, right? So please go through, in that same order, right? So that they will also get equal chance, okay?
Okay.
Yeah. Please continue.
Sir, I wanted to ask something about these live sessions. Will you provide different invite links for different weeks, or it will have the same common invite link?
For Replit, you're saying?
Yes, sir. Live coding on Replit.
No, the invite link is same. Once you join that Replit teams, new question will be added to that same team. You do not have to join anything new. Is that clear, Sandeep?
Yes, sir.
So right now you will see something called as week 1. Under week 1, you will see 8 problems, right?
Yes.
Similarly, week 2 will be, similarly week 2 will be added, and under week 2 we'll add few more set of problems, and we'll keep doing that on every Saturday, week by week. Yeah. So it's like, you have these activity questions, right? Every time. This time we are replacing activity questions with something else. So this is one point. We are going to add one more point in next few days. So you will see that as well. We wanted to cover some initial few weeks to give you, to build that foundation so that you can work on some slightly advanced problems. We'll bring that up. That's why in PDSA course, you will not see activity questions, which were there in other courses earlier in Python, CT, or they are there in diploma level other courses as well. So we are trying something new. We believe to be more effective than those standard activity questions.
Yes.
Okay, so this is one, and as I said, one more component we will be adding in upcoming weeks.
Okay.
We're working on that. Yeah.
I have one small request that in the video lectures, actually I found that the audio is actually very low. Means if I don't put the earphones, like for all of the lectures, like I have 3 diploma courses, and in all the lecture I find that the volume is a bit, or the audio is a bit low. So can you please consider this thing in the upcoming lectures?
Okay, sure. I don't think that's the case, and I'm not denying what you're saying.
Yeah,
But,
actually, just a simple example, because in others it's not visible. In app dev, actually, when the professor says that welcome to the app development course, you check the audio is quite loud, and when he starts the lecture, the audio is quite low. And for all the other lectures, the audio is in the same, that thing. So you can find the difference in the app dev. Just starting the 30 seconds, and the other you can see the difference.
okay, app
So
dev,
it will be great help. Like,
I can't comment on app dev lectures, but
no, I'm just giving a reference for the audio.
I
Like the
got
audio
the
is
point.
low in all of them. So please, check it once.
Yeah, sure.
Yeah, thank you.
Yeah, thanks. Yeah, Rajat.
Can I ask my
please.
question now, sir? Can I ask now, sir?
Yes.
Yeah, my doubt is regarding the graded assignment and the practice assignment for week 2. There are questions in which you have suggested the time complexity of the algorithm that we have to come up with. So, and you have used worst time complexity for the solutions. Like there is a problem of sorting in plus r time, O of n plus r time, and there is also a question in graded practice assignment where we have to solve in log n time the searching of the maximum element in a sorted and rotated list. So my doubt is, if I come up with an algorithm which is theta of log n, I mean, regardless of the input, my algorithm always takes log n time. Will it suffice to pass all the hidden tests, or only the worst case complexity will be log n, and you are expecting us to come up with better timings in case of favorable inputs, more favorable inputs? Am I clear in that question?
So I'm repeating your question. So you are asking about the means time complexity question, means is it efficient? You want to ask efficient time complexity for that question, means that suppose we have a sub, means we have a minimum time complexity for any programming question is log n. Okay, and so you wanted to know that we have to write a coding that will solve that problem less than log n or greater than log n.
No, not greater than. All I'm asking is, you are asking in the question you have asked that I have to come up with an algorithm that will solve the problem in log n time.
So if it is mentioned that it can solve in order of log n, so if you have a better solution that can solve less than order of log n, so definitely the hidden test case will be passed, because
No, sir, I don't have a better solution. Actually, in my solution, the worst case complexity is log n, but the best case complexity is also log n. So I am always taking log n time regardless of the input I am served with. But that may not suffice to pass all the hidden test cases. So that's what I'm asking. Have you designed the evaluation in such a way that if you give a very favorable input which will solve the problem in less time than log n? Log n is the worst case time, right? Sometimes it will solve in a better time than log n. That's what I mean by O log n.
Yes,
yeah,
of course.
Suppose I come up with an algorithm which solves the problem in log n times in all cases. I mean theta log n. Will it suffice to pass all the test cases, or I have to do better on my algorithm?
So if the question mentions that we have to solve it in order of log n or order of n, then it will suffice to pass all the hidden test cases also. But if it is not mentioned, then it is not passed some hidden test cases, then you need to improve your solutions. Maybe if you are solving order of log n, then you need to solve less than order of log n time. So it means log of log n. So then it will pass. So this kind of means time is set in the hidden test cases. But if it is mentioned that you can solve in order of log n, then it will pass in log n time. Maybe if it is not passing in the hidden test cases, if it is not passing your hidden test cases, then maybe your time complexity, you are calculating wrong time complexity, or maybe your program has some kind of means some kind of taking larger than log of n. That's why.
Okay, sir, I can't discuss it further because this pertains to a graded practice assignment. I'll get back to you once the deadline is over on this. I want to understand it in a more clear way. Thank you, sir.
Harshad Sahu raises hands.
Yes, sir. Actually, I had a doubt in one of the practice assignment question.
Oh, okay.
Sir, can you please explain that fifth question of practice assignment?
Practice assignment week 2 or week 1?
Week 2, week 2.
Oh, okay. Okay. Wait. That is related to merge the list. Hello?
Yes, sir. The fifth problem. Yes.
Merge list. Okay. So what is your doubt in this question?
Sir, actually, by looking at the function, first I thought that it should be m plus n, which is the correct answer actually. But see, because we check the loops, right? There are two loops. While loop is there, which is running, I think, n iterations and then m iterations. Okay, there is if else also. So my only doubt was, we have seen that if it is m plus n, then we take the maximum of that, right? Whenever there is m plus n order, we take maximum of that. So why is first option not correct? That's my doubt. Or when should we take maximum?
Okay. Oh, let me see the question. Okay.
Yes, sir.
Okay. So the question is that we have a two sorted list. Okay. So one is, suppose we have a one list 1, and we have a list 2.
So can you share your screen if you're showing that question?
Okay. Wait. So this is the question, right?
Yes, sir.
So we have a two list. So one A is list and B is another list, that is in sorted order. So and our main aim is to sort this, means combine this list and combine this list, and then we'll put all together as a sorted order. Okay, so that's a merge, part of the merge sort. So suppose, so what I'm saying, that how we calculate the time complexity. So our way to calculate time complexity is to look at the code and look at the problem what we are doing, means what program is doing. So for merging the two lists, so we have, suppose we have a list one. Okay, let me draw there. Where is the, so whiteboard is there. Eraser. So we will modify again. So you can see there A and B two list.
Yes.
So what, this is in sorted order, right? 6, 7, 8, 11. So what it take means, we have, this is our program, so we have to merge these two lists. So how time complexity we will calculate, let's see here. So what we are doing, we are comparing these two lists. Okay, so if one will compare 1 with 6. Okay, so if whoever is small, we will put in this list. Okay, so if 1 is less than 6, yes, 1 is less than 6, so we are calculating, we are putting 1 here. So this way we are doing that. Suppose 11, and we are doing 12 here also. Okay, so this is n, 4 point is there, and this is here m. This is, suppose this is 5 point there, m is greater than n. Okay, So one is we are calculating one, and sorry, we are comparing one with 6. Okay, one is less than one, so we will put here, and then we will move to 2. So 2 again we will compare with the 6. So this is less than, yes, so we will put here 2. Then we will compare 3 to 6. Yes, 3 is less, so we will again put 3 here. Okay, and then we will put 9. We will compare 9 to 6 here. So whoever is less we will put here. So 9, 6 is less, so we will put here 6 here. So then it will go to 7. 7 here is 9, means 7 is less than, so we will put here 7. So this is 7. So then it will go to 8. Yeah, this is 8. So this is 8, and then it will go to 11 and 9. So whatever it is less, so 9 will put here, and then we will, then the rest of the thing it will as it is 9, 11 and 12. Okay, so what we did here, that we compared every element, means every a of element to the rest of the b element, means whichever is less we are putting in the list. So suppose what you were saying that m is greater than n. So here m is like m 6, 8, 11, 12, m is 5 and 5, and here 4. So what we were doing, 5 is greater than 4, so you wanted to have a 5 time complexity, but here it didn't happen, right? Here we calculated each element to each element, like 1 to 6, 1 to 7, 1 to 8. So that's why we have compared all the n element. So whatever we calculated, then we put here in the original list or resultant list. So here we didn't take maximum of mn. We took the m plus n, because we are comparing all the elements. That's why we took m plus n here, not the maximum of mn. So, and I am referring to your doubt also, that so you also saying that like we have a 2 for loop and 1 for loop outside in the beginning. So there we were taking maximum, and here we are taking plus, uh, because that time order, because suppose one is nested for loop calculating order of n square, and one is a simple for loop that is outside that original for loop, and there it took order of n time. So there we will take maximum, because that main logic was, means how we calculate the time complexity, that major operation where is going on. So order of n square where the major operation going on with the highest time complexity. So that's why we took order of n square, and because this is taking order of n, so whole program will be like the worst case. What will be the worst case? That order of n square means whole the program is less than order of n plus order of n square. So we will means we can put it as a order of n square. Yeah, order of n square time complexity means order of n plus order of n square. So we will take as a majorly that order of n square is the time complexity. But here suppose here we are majorly dealing with the m into, means m plus n kind of thing. So how we can take order of m means maximization of order of m? It's like calculating, suppose we are dealing with one for loop. We have a means we have a nested for loop. Okay, so one is like 1 I is equal to 1 to n square. Okay, and second one is I is equal to j is equal to 1 to n in the nested for loop, right? So you are taking that, why we are not taking order of n square instead of order of n cube? So you got it?
Sir, so that means if we have multiple loops inside one program, okay, so if let's say the first loop is going from 1 to n, so its complexity is n, right? And if we have another nested loop and n inside also n, so that is n squares. Okay, so in such cases, if we have one loop is n another loop has complexity of n square, the nested loop. In that case, we take the maximum, the highest order, n square.
Sorry. Wait. We are not taking maximum. You didn't means you you chooses wrong idea that we haven't took maximum. That like order the time complexity will be order of n plus
order of
n square.
So the complexity will be n square plus n.
So order
and then
of
we say the order is n square.
Because
Okay.
like we have a iteration like 100 and 1000 2000, so 2000 square, and then 2000 will be less means we can it's like epsilon. We
Okay.
can neglect that kind of thing, so that's why we took order of n square. We never took max.
So can I say whatever are the loops? Okay, if let's say if the two loops we were talking about is n square plus n that we did, that is one equation we get, n square plus n, and from that we find the highest order.
So like you have already solved that kind of question like 2n square plus 3n. So 2n square. So what is the time complexity? So suppose we are dealing with n is equal to 1000 2000. So 2000 square is far means a big number, 2000 square compared to 2000. So we can neglect 2000. So that's why we just neglect it and say that order of and suppose, and you know that BIGO notation, right? BIGO notation is so can I ask you what is BIGO notation? What do you means? What you understand about the BIGO notation?
Sir, that big O notation is it's the upper bound, or we can say the maximum time, the worst case time we can say for the program to run.
Means it's a upper bound. So that's why we took big O of n square. Like big meaning of the big kind of function gn. Suppose gn, big O of gn, any function we are dealing with, fn is equal to big O of gn. Okay, fn is like any kind of function. So big O tells us we have a we can choose any kind of thing, means any we have to choose any c value, like fn less than is equal to cn, c g of n. C means we have to choose any c, any kind of c for n greater than or equal to some bigger number. So then it will be less than. So we have to choose c and n naught. Any number is, if that is the proper definition of big O. How we are, why we are taking as a upper bound means. So I have to say, suppose we have a 2n square. Suppose we have a 2n square. So and we can say that n square. Okay, one is n square and one is 2n square. So here we can say that n square is less than is equal to 2n square, because we can find any c such that 2n square will be, means we have a cn square, so we have a 2 into n square, so 2n square definitely will be bigger than n square. So we find that we find that c here, there exists a c, we can say that. So that's why we take a bigger number, and so that's all.
Okay, sir.
Okay, Sandeep.
Sir, there is one more question I had.
Before that, so Harshad, have you understood why it's m plus n? Why not option A?
Sir, actually, I got confused in this thing now, because in the lectures I saw something related to this. When we add the two things, then it is maximum of that. I also have the slides in front of me open. Should I share my screen? I mean,
I don't think you will have right to share your screen. So if you can tell me which lecture.
Sir, it is lecture 2.2, comparing order of magnitudes. Lecture 2.2.
Just hold on. Okay, 2.2, right? Okay, slide number.
On that PDF, I think it is. Sir, it is under useful properties.
Okay.
So it is 15th page of PDF.
Okay, 15th page. Oh, that's total. Okay, 15 page. Yeah. So see, over there, it's everything is in terms of n, right?
Okay.
But over here, okay, let me then, I mean, that's what I assume, and that's the confusion which you have. Okay, over there, everything is terms of n, right?
Yes.
So over here in this particular merge program, whatever you got confused, right? If that's the case, if you look at those two while loops, right? One which starts at line number 19 and other one which starts at line number 23.
Just a minute. Let me just...
Okay, hold on. I will share the screen. Can okay, I can. Okay, can you see my
yes,
screen?
Yes, I can see now, sir.
There will be too many tabs, but yeah, fine. Okay, so if there are three loops, right? Majorly, I mean, that's what we will look for complexity in generally in any code, right?
Yes.
So if you look at this code, which the loop which starts at line number 11, this while it says I is less than m and j is less than n. So for how many times this loop will run?
I think less than, right? So the lowest number, whatever is there.
I mean, whichever is lowest among m or n, those many number those many number of times this will run, right?
Yes, yes.
Okay, then that will be the complexity for I mean running time for that particular block of code. I'm not talking about entire program. Okay.
Okay.
Then move to next while, which is starts at line number 19.
Okay.
Which is m, right?
Yes.
So whatever was there for this line number 11 plus m, that's what we got, right?
Yes.
But this okay, and then for this third while it will be n.
Yes.
So this small portion plus m plus n, that's what the actually that's the running time for this particular code, right?
Okay.
But this is very small portion as compared to m and n, and this is again in terms of m and n, right? This value will be either m or n, right?
Yes.
But definitely this is less than this m plus n.
Okay,
Correct?
so the first while loop, we can say it is minimum of m plus n. I mean, it is less than.
Yes,
less than m.
which is definitely less than m plus n, right?
Yes.
Hence, we can ignore that because it is in same, in terms of m or n. If you are calculating, let's say something x, y over here, then we would have considered that as well.
Okay.
Because we don't know how large that will be. If it this, for example, it is I less than x, j less than y.
Okay.
Then we would have taken mean of x comma y as well.
Okay.
Because we cannot predict whether x and y will be higher than m or n or not, right?
Yes.
But in this case, definitely mean of m comma n will be definitely less than m plus n, correct?
Yes, yes.
Without doubt, we can say that
yes.
That doesn't matter what values are there for m on n. That's why we'll ignore first loop, but we will consider next two loop and consider it m plus n. Whereas on the other hand, if both loops are in terms of n, let's say, okay, this line number 9,
yes.
Okay, I less than n, then it becomes what? N plus n.
So that will be n only. I mean,
that is 2n. That is 2n, right? And 2n, then 2 is your constant, right?
Yeah, so order is
then you ignore 2, then becomes n.
Okay.
That's how you decide whether to merge that and ignore it. I mean, ignore some value or to retain it.
Okay, sir. So here, because these m and n are two different sizes.
These are two different entities, right? We cannot compare them like that.
Okay. So and on the slides that we were talking, it is when we have the same n.
Same entity, yeah. See, if n value is, let's say, 1000, it is 1000 for everywhere there is n, right?
Okay.
But here n is 1000. That doesn't say anything about m. M can be less than 1000 or it can be even billions, right?
Okay.
So in that sense, you should add up both.
So basically, we should be careful when there are different quantities like this.
Correct. See, it completely depends on how many variables are there. If it's a constant, you can ignore it. But if it's a variable, you should consider it. Or if and on top of that, if there is a variable that itself it's going to be very smaller than some other variable, then also you can ignore, like what we did for this loop which starts at line number 11, right?
Yes.
That's also a variable. It will be
Yes.
either m or n, but definitely it would be lesser than m plus n, right?
Yes.
So even though it's a variable, we are sure that it's less, then we can ignore it.
Yes, and that can be also seen here because they're taking less than, so it has to be less in
Correct.
the first while loop itself.
Correct.
Okay, sir.
So it's not like there is no standardized formula for something. Okay, it's not like some mathematical formula you mugged up and just applied it. It's logical reasoning has to be applied along with this thing to get the actual complexity.
Okay,
that's
sir.
how I will put it.
Thank you, sir.
Yeah. Yeah, you are asking some other question.
Yeah, so the other question was again from this thing only. The third question, where we are talking about fn is equal to 5n cube plus n square plus 6n plus 2. So there we can easily find out that big O, that it will be n cube. That is fine. But I am doubtful about the other two, theta and omega. It is the third question of practice assignment.
Yeah, right. Rajat, do you want to take it or do you want me to continue?
Yeah, whatever. If you want to.
No, it is better. You do that.
Oh, okay.
Yeah, continue it.
Yeah, yes. So you know that omega and theta, right? So omega is the lower bound as big O is upper bound, and theta is tight bound, means lower and upper both.
Both.
Okay. Yeah.
Yes, sir. So I'm quite sure about that big O, it is n cube. That
obviously
questions. That's the doubt.
Okay,
I'll
I'll not I'll not provide the answer, but yeah, I'll just give you a hint that suppose we have a means I'll just give you a right definition that big O of fn, you are talking about fn, and big O of n cube, or sorry, omega of n cube. What it means we have to check cell that fn greater than is equal to c of n cube or not. Fn is greater than is equal to c of n cube or not, means you have to, as in the big O notation, that you have to find any kind of c, means any kind of constant number that will prove that it is greater than, it can be greater than or not, means you got my point or not, means c into n cube. So can you suggest any c which can be less than means fn can be greater than that c n cube or not, or got it or not? Means
greater than is
greater than equal to
O, right? It is for big O, right? That greater than we find.
No, means fn what fn is equal, fn equal, suppose fn is big O of n cube, means what? Fn is less than is equal to big O of n cube, c into n cube. It is right or not? C into n cube, we means you can find any c. So you know that if you are dealing, suppose let's say c is 8 n cube, okay, or 10 n cube.
Okay.
C is, suppose c is 10, c is 10. So fn is 5n cube plus n square plus 6n plus 2. So if we put c is 10, so 10 into n cube will be greater than this 5n cube plus n square plus 6n plus 2 or not, means, and for n greater than equal to n0, n0 is the number we will choose. Does it true or not?
Sir, so that means that 10, you're talking 10 n cube. So we should select a number which will give us a value which is greater than fn.
So means we will select c and n naught. For n greater than equal to n naught, there exists c, means this is the definition that there we have any c such that fn is greater than, fn is less than is equal to c into n cube or not. means
Yes,
we
we
have
can
to
have.
find C. So that's why you said that big O of NQ is the answer. So we
Yes.
can have, means if we put 10 into NQ, C is equal to, suppose C is equal to 10, and 5 NQ plus N square plus 6N plus 2. So definitely we found C is equal to 10, so that C 10 into NQ will be greater than that 5 NQ plus N square plus 6N plus 2 after some iteration, means after some N naught. N greater than equal to N naught is also there, means N
Or
naught
we
will,
can say for a large n, we'll easily get 10 times n cube will be greater than this fn.
for large N, means you have to find out, means
Specific n.
there you have to find out N naught and N, for which N naught and for which C it will be, it is true or not. If you find out that that C is there, C is 10 and N naught is some 5 or 4, then it will be a big O of NQ, otherwise it will not. So got it? So
Yes, sir.
in the same manner, you have to find out B, C and N naught such that Fn is greater than equal to C into NQ or not.
Okay.
So
this
if you find if you find out any C and N naught, then it will be true also. And the same will be theta NQ, omega NQ. So hence you can choose.
So for omega, we have to get the value less than fn. Is
Fn,
it?
yeah, means omega value, means Fn is greater than, omega C into NQ. We are dealing with the omega NQ, means C into NQ is less than is equal to Fn.
Yes, yeah, understood. So we have to search for a possibility if there is a C and there is n naught, which gives us a value which is less than fn.
If you find out, then it is true. Otherwise, it, and for the same, and it is for the same as theta also, means we have to find C1 C2 such that f of n is less than is equal to NQ and C into NQ, and f of n is greater than equal to NQ. If you find out those two things, those two C1 C2, then it will be the theta will be the answer. If you find out that omega NQ is true and omega NQ is 2 and big O of NQ is 2, then automatically theta NQ will be true, because you already find out C1 C2 for omega, and you know, you are getting
Yes,
my
yes.
point.
If upper bound and lower bound are same,
You
then the tight bound will
theta
also be the
also
same.
theta already will be true, so this way we can calculate. Yes,
fine. Sir, I had a doubt in this because I mean when we talk about that time complexity, so we say that omega is the best case best case time complexity, and big O is the worst case time complexity. So why for this question we are getting the same answers? Like the correct answer is O n cube, okay, omega n cube and theta n cube. So I was confused because when we say omega is the best case complexity, so it is the same for both for worst case as well as for the best case.
I got it. Can I explain? I solved that question, sir.
Okay.
yes,
Yeah.
definitely.
Yeah. So, hi, Harsha.
Hi.
Actually, what's happened? No, it is the depend on the situation. Sometimes we have a linear function. After practice some question, no, it will come as idea. So sometimes I have a complex function like the linear as well as the logarithmic and log n. It is the multiplication of the two functions. So I have some facility like that. I have some polynomial function. I have written on the chat box. So once I solve that, so what's happened sometime in the polynomial function, I can fix some the constant or the some x c value and the n naught, for which in the same polynomial can be bigger by the same degree of the other function and can be lower by the same degree with the some other constant. It is happen in the polynomial function. So can you see in the chat box I have written?
Yes, I can see that n cube less than or equal to 5 n cube plus.
Yeah, and as the sir told in the lecture, it is the smartness of the people who can find. There is a multiple solution. So one of the solution I just wrote. What I did, so n square I made everything n cube. So 5n cube plus n square, no. So everything I made n cube. So if n equal to n naught 1, it will be lesser than that 13 n cube, isn't it?
Mhm.
So and the same polynomial will be greater than that n cube always for the any value greater than 1.
Okay.
Yes, Priyanshu.
So that we can write that it has the big O notation is also NQ, and the omega notation is also NQ. Since both has in the same degree, so we can also say that theta is also NQ. So
Okay.
here option 3 is correct.
Option, yeah, 3 is correct. In fact,
all 3 is correct.
all 3, 2, 3 and 4 are correct. So we can say in this question, we have first checked if there is a
omega.
There is a, yeah, no, first we could check that big O, that
yeah, big O,
for
and then
some
big omega.
C and N naught, we can have Fn less than that C into N cube plus N naught.
Yes.
Right? We proved it for greater, we proved it for lesser.
Yes.
Okay, that means we did it for big O, we did it for omega. So automatically satisfied that it is theta also.
It is on the same degree, so it's the theta.
Okay. So if it is true for this polynomial function, is it going to be true for every polynomial function?
It is necessary. It is not, but because sometime if a smooth polynomial is there, yeah, we can make. If polynomial
because it is polynomial of degree 3, if I take any polynomial of degree 3,
yes,
is it going to be the same thing?
Yeah,
because we can just manipulate the numbers.
Correct. I think also.
That's what I wanted to know, because I thought there must be some mathematical calculation involved in this, but it is not like that.
It is not. It is pure on the intention.
So we can say that if it is polynomial of degree 3, then it is big O is n cube, omega n cube, and theta n cube.
Yes, in that case we can say that.
Okay, I hope this is correct.
Yeah, but if we make that, if we add some logarithmic here in the addition, so it's a little difficult to say.
No, that's okay. That I understood. In fact, finding those value of n naught and c is also some calculation will be there. But I just wanted to know if it is plain polynomial of degree 3, then these 3 answers will always be correct.
Yes.
Okay.
Okay. So any doubt?
I have a doubt, sir.
So can I ask?
Yes.
So. Sir?
Yes.
Sir, I was having some doubt in merge sort. Can I ask?
Yes.
So, sir, actually, I was confused with the merge function that is told and the merge sort function.
What confusion?
So I understood the merge function part, that we have to, how do we have to merge two lists into a third list by comparing the value, but I didn't get why did we apply the merge sort, like what's the role of merge sort here? The recursion part of the merge sort, I didn't get that part.
Recursion means we are just dividing the list into half. That's what.
So in merge sort it is written that L is equal to merge sort A till the half of n, and for right it is written from half to the length of A.
So
in the
okay.
analysis in a week in the 2.8 lecture.
Okay. So how merge sort works? We just divide our whole array or list into half of the parts, and then we just took one part of the, like if we have a middle part, then we will take that middle part, and otherwise we will just divide that, we will take other parts, and then we will divide this part and this. This is the way, means I don't understand what is your doubt means.
So like, so if you can see the analysis of merge sort 1, there is written in the merge sort function, L is equal to merge sort A from 0 to n by 2.
Okay.
And for right, it is written from n by 2 till the length. And then it is written B is equal to merge L and R.
Okay. Okay. Suppose we have a uh, 6, means array have we have a list of length 7 and indexing 0 to 6. Okay, right? So we will divide 6 by 2 is 3, so we will take 3, and then after this 3, after this, then we will take into the another list, means up to that end of the list, means it is from if it is 3, then 0 to 3, and then 4, 5, 6 is in the another list.
So like sir, in merge sort, if we have 6 elements, then we would divide it till we get 6 individual lists of each one element, right?
Yes, of course.
And then we would start merging it, right?
Yes. Then we will yes, then after we will come up to the stage where we have a 2 sorted list, then we will merge them to become a more whole sorted list. So that's how it works.
So it is written L is equal to merge sort 8 till n by 2, and R is equal to merge sort from n by 2 till length of n, length of the list.
Why I'm saying in the Python, suppose we have a for I in range 0 to 2, so it will go up to 0 and 1. It will not take 2, but if we'll take 2 to 5, then it will take 2 and n by 2. So
yes,
n by 2
I got that part. I got that part actually. I was confused. Like, sir, we have to first divide it till we get list, or we have to divide and then we have to merge. Is the divide and merge function going simultaneously, or is the
no, first we will divide, and when we'll divide until we get a 1 list or 1 element, and then we will start.
We will divide it till the end.
Then we will merge, means this we will go up to the depth, and then we will start merging together, and then we'll just get up to the 2 sorted list, and then we will merge. So first we'll divide and then we'll merge.
So like, so how would we know? So like, how many times would the merge function be applied? How many times?
Suppose we have an element. Okay, so we will in each step we are comparing with the n elements. If we have an element, so we are comparing n elements. So we are suppose we are merging 1 times we are merging. Okay, in the last step we are merging 1 time. Suppose we are taking, so in the what is the height of the things, with height of the tree, that list is divided into 2 parts, then 4 parts, then 3rd part. So if we are considering, we are taking 1 merging, as suppose we are otherwise we are merging many times, means we are dividing into n by 2, so 1 1 2 1 1 2 1 1 2 in the last step. Suppose we are merging in we are taking it as a 1 merging in the first step, in the 1 step. So log n times the height, you know that height is the log n, so we will merge into log n times. So log n times we will merge.
So like, if you can see the merge sort function that is given in the week 2. Lecture 8, so there it is written LR and then B. So like, in the merge sort function, first it is checking that the n is less than equal to 1, so we will return the A. Then it is checking L and R. So like, after it would, like, if for example, if n is equal to 6, then L would be the first 3 elements and right would be the next 3 elements. After that, sir, would it again divide? Would it again go to the recursion, or would then it go to the B part, that is merge is equal to B is equal to merge LR?
No, first it will divide and then it will merge. First it will divide and divide. It will call itself and divide.
And then at last it will go to the capital B.
And then it will, this is the means simple concept, that it will divide and then it will merge. You just take this first it will divide and then it will merge. So according to that, you can understand this algorithm.
So is there any recursion function in the merge also, right?
Yes.
Would there be any recursion function in merge?
Yes, because we are merging each time, right? Means suppose we are dividing up to the end, we have we got a 1111 list, means one list we have a one length of list. So then after we are merging them, and it becomes two length of list 2. So we are merging here, and then again we will call merge function, and then we will merge list, then we will merge two list and two list, then it will become four list, and then two list, then it will become four list. So we have to call a merge function again. So it is, that's why it is recursive.
So first all the dividing would take part till the end, and then all the merging would take part.
Yes.
First the recursion of merge sort would take place, then the recursion of merge would take place, right?
Yes.
Okay, sir.
Hello, sir.
Yes.
Can I ask one question? Can you go on the graded assignment questions? I feel that one question solution is wrong. So
okay, graded.
Can you share that screen, sir? So,
okay. Okay. Which assignment?
the second graded second assignment. Yeah. The 10th question. Yes. It's look like that for me. The both 3 and 4 option is the same.
3, F2, F3, F4, F5.
And also none of the correct.
Why none of the correct?
Because it is not correct, sir. Because F1 is greater than F3.
Hey Kumar, this is graded. We will not discuss this at that detail. Whatever you are saying that there is a repetition with respect to
Yes,
option
sir.
number 3 and 4, that's correct. If you feel that that's the correct answer, you submit either of those two, you should get marks. Or else, if you think A or B is correct, you can submit, and that should not be again a problem. Okay.
And sir, if feel that none of the correct, then?
That's not the case. I assure you that correct answer is there in one of the options.
Oh, okay. I will
Okay, that much there is nothing wrong in question except that the options are repetitive. But if you feel that's the answer, and if you submit either of those,
okay, sir.
You will get marks. That's all. That will make sure of. Okay.
Okay, sir. So one of the correct answer.
Yeah, answer. I mean, correct answer is there in the option. Which one that you have to see?
Oh, okay, sir. Sorry, sir.
Nothing wrong in the question. Yeah.
Okay. And one question more, sir. Hello.
Yeah. We'll take last question and we'll stop. We already crossed the limit. Time limit.
Yes, sir. Just for you, sir. For Omkar, sir. The last time you gave the homework that to select the merge sort and the as well as that sort and sorted list.
Yeah. Right.
So I solved that. I thought that once he will come, then I will ask you.
Okay.
So I got one thing: merge sort and the sorted list is taking the same time, but L dot sort, array dot sort is taking half of the time.
Half of the time. Okay.
Yeah. So I want to. So what is that actually? I'm sending you, sir. That. 1 second. Yes. So here.
You're sending something on chat or something?
Yeah. So it is taking. I was sending copy. So this is the list I run that I have taken the average scenario. This is that when I'm using the sort, L dot sort. So this is the 10 times I run and I have taken the average.
Okay.
So that is the
It's
for
point,
the
0.04.
yeah,
For
and
how
this
many,
is
what was your input size?
sir, it was that 1 million random data between 1 to 1 million.
Okay, fine.
So I created the using the random function.
Okay, this is using which sorted, right?
Yeah, L dot sort.
L dot sort. Okay.
Yeah. Above is L dot sort. This one.
Yeah, got it.
And this one is that this one is sorted L.
Sorted, right? Yeah.
Yeah, sorted L. And the last one I'm sending you, sir. That one is for the merge sort, which we developed,
Right.
handmade.
Yeah.
So this is for the merge sort.
Which is almost equal to sorted, right?
Correct. So yes.
Right. Then have you tried with quick sort?
No, sir, because that I didn't get time.
Okay.
For that,
Fine.
but a quick
Fine.
sort
So
has
based
that,
on these numbers, what's your judgment? What you can say about that sorted method?
I'm seeing that L dot sort is that the faster double of that, and the sorted is that and sorted and merge sort is that this thing the same ratio.
Correct.
But and one thing also, L dot sorted is not taking extra content, but the sorted L is returning in the some other variable, so it is creating other content.
Correct. So over there, it is saving on time, but it is using some extra memory.
So it is using that for that purpose only.
Yeah, I mean, see,
Double up time creating another list.
Okay. No, not necessarily. Okay. I'm not saying in that sense. I'm saying, see, whenever you do sort, right, there are two ways to sort, right? Either in place sort or you create a new list and put sorted elements there, right?
Correct. Yes.
Correct. So whatever numbers you shared, it is with reference to only time. Of course, we do not think too much about this space complexity, but that factor is also there, right? So that's all I just wanted to point out. I mean, as you are comparing, I mean, it's not that critical aspect, but it's something which worth considering as well if you are considering that large data.
Oh, yes. I didn't notice till now until unless last class you told me that too.
Correct. If it's a small list, we don't care, right? I mean, it's a small list. Okay, fine. If we create another copy of it with sorted version, we don't mind. But if it's a really huge data, then sometimes we do have to consider that as well, right? If we are processing, like sir initially started with Aadhaar card data, right? If you are sorting something like that, then definitely we have to consider space also along with time, right?
Yes.
Right. Otherwise, most of the times we ignore that. But as we are comparing these algorithms, sometimes it's worth considering that factor as well.
If it is the 10 million or the more than the 10 million, then it will worth to use the L dot sort.
Correct.
Yes, sir.
So it depends on your application's requirement, honestly. Yeah.
Yes, sir.
So now, whenever you get time, try this quick sort also with same input size. Okay.
I have heard that, I have read also, sir, that in the quick sort, it can become, it is very flexible type of thing. So if there is a pivot point, I have to choose smartly.
Correct. It depends on how smartly you choose pivot.
Yes.
If you don't do it smartly, it will be the one of the worst algorithms. Yeah.
Correct. It's go bust algorithm.
Yeah. Correct.
Yes. So and one thing also, this way can we find that what is the time complexity of that algorithm?
Which
I have
algorithm?
I have one idea like that. Which time? What is the time complexity of the sort method and sorted method?
Right.
So I can do one thing. Suppose I have taken the 10 million and I have taken the average, no? So if I can take the 10 million, 10 to the 100 million, 1000 million, like that, 10 data I can take on the series, and I can see that what is the time complexity is making, and after I will plot the graph of the time complexity, I can fit that point is fitting the which graph, then I can say that this particular algorithm is taking that time complexity method.
Yes, of course you can.
Okay, so this is my method is correct. We can find through this method
Yes,
of
you can.
the
I mean, of course, it will not be the accurate one, but you can somewhere ballpark it, and roughly you can give some some analysis on that. If you can plot it, you can easily see that that curve, right? If you plot a graph in that way, you will easily see that curve growing either exponentially or in terms of some logarithmic way. Yeah.
Correct. Okay. Yes, sir. Yes, sir. That was my point.
Yeah. But for that, you will have to execute it for those many number of times and those many different variations of the input sizes you have to fit.
Yes.
You require sufficient data in order to make such kind of, I mean, to derive such conclusion, right?
Yes. So we can generate through that the random.
Yeah. That, I mean, yes, of course. So that's what I was going to do. Don't do manually. Write
Yeah.
some
Yes. Obviously.
script and do it through that. Yeah.
Yes. Yes.
Yeah.
That's the thing. Okay, sir. That's the thing.
Okay. Yeah. Okay, great to see that you actually went back and did it.
Yeah. I did that days also, but I was waiting for you to come in the class. So
okay.
Okay. Thanks, sir. To
Okay.
reply.
Thank you. Yeah, Rajat, over to you. I think we can close now.
Yeah, shall we close or means?
Yeah, I think we can close.
Yeah. Bye, everyone.
Yeah, everyone, thanks for joining. Just we will close the session. If you have more queries, forum is there, or we'll meet for next session. I mean, there will be a next session tomorrow afternoon. So if still something is there, you can join that.
What will be the tomorrow's class in that?
It's open session. Tomorrow, see, Wednesday and Thursday will be open session. Saturday will be a live coding. That's how it will be throughout the course.
Okay, sir.
Okay.
Thanks.
Yeah.
Yeah.
Okay. Bye, everyone.
Yeah. Bye, sir.